Hello and welcome again to one of my video lessons. And this lesson is about HTML canvas programming, and this time we are going to study some advanced operations on the canvas and how we can modify the coordinate system that we use in drawing. So here I'm supposing that you are already familiar with the basics of canvas drawing, like how to draw rectangles and how to draw lines and how to draw paths and so on. But this time we are going to rotate and scale and do such things with a coordinate system. So this is a little bit more complicated drawing, and again, I will go to this naturalprogramming.com, and there you will find a page like this. Actually, you can find the page through when you first go to the main page, and then you click this web icon, and then you select the canvas-based pages, and from there you can find a program or page called Flying Arrow Canvas. So I have already downloaded it and I have it open here, as you already saw it. So the page looks like this. So there is the canvas area is there. It has a light gray background, and then I have drawn there 4 purple arrows, and then I have drawn a couple of hollow arrows there. So I have already this source code of this page. I have already here in the text editor, and let's study it. So this program demonstrates how to modify the 0 point of the coordinate system, how to rotate and scale the coordinate system, and how to write functions inside another function. So, and again, if we take a look at the end of the source code, we'll find that the end of the page is quite the same as in many of my other canvas related pages. So with the style definitions, we center the canvas area in the page, and then we have inside the body of the HTML we have this canvas element, and we have a method named draw on canvas, which will be called when this page loads. And so we will take a look at the draw on canvas method. And we don't have any global variables in this program, and we have the usual things like first we get the context for drawing, and then we fill the background of the canvas area with a light gray color, and then we set the fill style or the filling color to purple, and the outline color or the stroke color is automatically black. And then we have here a function inside a function. So we are now inside this draw on canvas function, and here inside this function we have another function called create arrow path. So in JavaScript this is possible, and it's important to know that this function that is used inside, or that is written inside this other function, it can refer to the variables defined in the outer function. but so it's not possible to use this variable out of this outer function. So its function name is create arrow path, and then we have this actual statements of the function called draw on canvas. And there we could study this first. So there we have first called to context.translate method. And this means with this translate method call we can modify the so-called 0 point of the coordinate system. You have certainly learned earlier that the 0 point is normally the upper left corner of the canvas. So if in normal coordinate system the 0 point is here. So this is the 0 point, and the y coordinate, the x coordinate grows when we go to right, and the y coordinate grows when we go down. This is different than the mathematical coordinate system. And then now it is possible to modify this coordinate system. And so inside, or in this page, we translate the coordinate system so that it is moved 150 points in x direction and then 250 points in the y direction. And then we create the arrow path, and then we fill the path. So this means that after this translation of the coordinate system, that we will draw the arrow like this. So this arrow is drawn by the first fill statement there. And then we rotate the coordinate system 45 degrees clockwise, which is math.pi divided by 4 in radians, and then we again create the arrow path, and then we do the context.stroke method, which means that we draw a hollow arrow using the default black color. And so the second drawing operation makes this arrow, and you see that the coordinate system is now turned 45 degrees clockwise. So inside, so this system works so that inside this function we always create the arrow path, and we then when after the coordinate system is modified, the path is different, and it draws a little bit different the arrow in a different position. And inside this method create arrow path, we have two arrays, or two initialized arrays, and these have coordinates in direction x and coordinates in direction y. So you should read, when you read this, you should read the coordinates like 0, 0, 15, 40, 5, 30, 5, and 120. So these are the coordinates of all the sharp points or turning points of the path. So that, for instance, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 coordinates. Or then 10 pairs of coordinates. And when you take a look at the page, you will see that an arrow has 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 points through which we can draw the arrow. So what this actually does, it uses this begin path. So we make a new drawing path, and then we move to the first pair of coordinates in these arrays, and then we use the point index from 1 to the length minus 1 of the arrays, and then we use the line to method to make the drawing path. And this way we can draw all the points that belong to the array, the arrow. I'm sorry about my pronunciation, so it's arrow and array. So we draw arrows and these are arrays. And in the end, we close the path as usual. So this function always recreates the arrow path in the current coordinate system, and when we modify the coordinates, we get different arrows in different positions and in different orientations. And you should also notice that when the 0 point of the arrow is or the first coordinates of the arrow is 0, 0, which means that the tip of the arrow is in that position. So if we modify this page source code so that we remove this first statement that translates the coordinate system, and if I save it and I reload it, you will see that this is how the arrow is drawn without any modifications to the coordinate system. And you see that the first point is 0, 0, and the second point would be 15, 40. So this is actually this point here, it is 15, 40. And so the path goes through all these points, and then we get the full arrow. Well, I will modify the program so that we get the original one, and I reload it. Like this. So we first that the coordinate system in the first drawing operation, the coordinate system was moved to this point, and then the coordinate system was rotated, and when the program continues, you will see that then we translate it again 0 in x direction and minus 200 in y direction. So, and then we recreate the arrow path, and then we do the fill operation, and so then we get this arrow. So the distance from this point to this point is 200 points. And again, we rotate the coordinate system 45 degrees clockwise, and then we again translate the coordinate system with minus 200 points in direction y. and then we fly. So this means that we would go up in the normal coordinate system, but now that the coordinate system is turned twice by 45 degrees, so it has been turned altogether 45 degrees, so in that case we go to the right, as this comment says, and then we get this arrow here. And then there are two more drawing operations, and again we fly up or to the right to 100 points, and then we again rotate the coordinate system, and now we rotate this 90 degrees clockwise, which means that it is rotated altogether 180 degrees, which means that the coordinate system is upside down. And then we also scale the coordinate system. We use this scale method, and we scale both in direction x and both in direction y. We scale 1.5, so everything will be magnified by 1.5. And in the end, we translate the coordinate system again by 200, and this means that then we are going down instead of up, because the coordinate system has been rotated by 180 degrees. So with these two stroke and fill operations, we get the last two arrows that are visible here, and you can see that they are now bigger arrows as the coordinate system has been scaled. Yes. So it is quite interesting to, or you can make very interesting drawings with this by scaling and rotating the coordinate system. Maybe we could take a quick look at the documentation. So at the web programming, or in the web programming page, I have a link to HTML canvas methods and properties. And here you see this transformations, so that there's a scale and there is rotate and translate, and I think with these methods you can do all these operations together. So it will be useful to study these as well, and also I think there are very important methods there called save and restore. So it's possible to save and restore the coordinate system when you transform the, so you can do so, or we will probably later on see programs in which we save the current state of the coordinate system, and then we modify the coordinate system, and after we have done the drawings with the modified coordinate system, we use the restore method to bring back the original coordinate system. So this might be useful sometimes. But I think this is enough about this program. So, but it is important for you to know that these kinds of operations with a coordinate system can be done. So I again thank you for your attention, and I will be back with some other video. So thank you and goodbye.